Hi everybody. Today I'm going to be going over Chapter 4, Question 13 from the Bingo Questions. So this one is pretty straightforward. It's dealing with an acceleration versus time graph and talking about or asking questions about what's going on with that graph. So let me first read the question for you all. It says, a 4.5 kilogram experimental cart undergoes an acceleration in a straight line, and then in parentheses it says the x-axis. The graph in figure 13 shows the acceleration as a function of time, which I drew up here. And then it says, part A says, find the maximum net force on this cart. When does this maximum force occur? And then part B says, during what time is the net force on the cart a constant? And then C is, when is the net force equal to 0? So we have 3 parts here. They're all pretty simple. And we are able to get a lot of information from this graph that was given to us. So let's start with part A. So it's talking about what the net force is on that cart. And so, if we remember, force is mass times the acceleration. So, since this is an acceleration versus time graph, since the mass is constant, right, the mass, as it said in the problem, is 4.5 kilograms. So since that's constant, the only thing that's changing the force is that acceleration. And so as we look here, the maximum force on the cart is going to be when the acceleration is the greatest. So if we look here, that time period is going to be, or first of all, it wants the value. And so we can see that it peaks out at 10 meters per second squared for the acceleration. And so that's the very highest acceleration the cart is gonna undergo. And so since we know that the force is really, since the acceleration is the only thing changing, then we know that if the acceleration is at the highest, then that's gonna be our max force. So we'll use that, so it'll be force equals the mass, which is the 4.5, times 10, since that's our max acceleration. So when we do that, we end up with 45 newtons. So that's the maximum force that is acting on this cart from the time period that we're given. So that part of part A is done, but now part A also asks what time this occurred during. And so we can tell that that occurred from 2 seconds to 4 seconds, because that's when the acceleration equals 10. So from 2 to 4 seconds, that cart was experiencing the greatest force. So that's it for part A. So we'll just write it down. So 45 newtons at t equals 2 to 4 seconds. So that's it for part A. Part B, when is the net force a constant? So the net force is going to be a constant when, when the acceleration isn't changing, right? Because we already talked about in part A about how the acceleration is what's changing this, right? The mass of the cart is remaining constant within this example. And so when the acceleration is constant, the force will be constant. And so once again, just like part A, the acceleration or the net force is a constant between that same time period. from 2 seconds to 4 seconds. Now part C wants to know when the net force equals 0. So once again, we go back to our equation in our graph. So we know the mass isn't changing, so that means that it's all due to the acceleration. So does the acceleration ever equal 0? Because that would make the net force 0. And we can tell right here at the time equals 0, and then over here, which is time equals 6, that indeed the acceleration is 0, which makes the net force 0. And so the net force is equal to 0 at t equals 0 and t equals 6. And of course that's in seconds for our units. So that's it for question 13. Pretty straightforward. Really, this exercise really helps us use graphs to be able to see what's going on with the acceleration and be able to tell when that net force is the greatest, when it's constant, and when it's 0. Thanks for watching, and I hope you'll see us again soon. Thanks.